Okay, we're asked to apply function notation all to this function with these expressions. So pretty much did this right. First of all, f of x is x squared minus 4. We'll just put it there where we can refer to it. So if we want f of 3, then x must be 3. So that's 3 squared minus 4. If you do the arithmetic, that's 5. Okay. So now f of 4 minus 1. It's not f of 4 minus f of 1. Okay, it's just f of 4 minus 1. Okay. And 4 minus 1 is 3. In other words, you don't have a distributable function notation. Okay. And f of 3 is, as we saw, thought I'd give you one that you'd already done, so you wouldn't have to do all that one. Okay, now f of 4 over f of 1. And 4 squared minus 4 over 1 squared minus 4. Because f of 4 is 4 squared minus 4, f of 1, x is 1, it's 1 squared. This can get a little confusing. 16 over minus 3, which would use the brackets. Negative 16 over 3. Everybody with me so far? Think so. Again, what I saw, there might have been a few little mistakes. Now I'll put off f of r bar the last. 2 times f of 3. You don't multiply 2 times 3. You find out what f of 2 is. You find out what f of 3 is. So f of 2 is 2 squared minus 4. F of 3 is 3 squared minus 4. And if you work it all out, that's 0 times 5, which is 0. I think everybody got a 0. Okay. Now, f of r bar equals, well, now x is r bar. So that would be r bar squared minus 4, wouldn't it? Okay. Whatever's in here, you go to square it and subtract 4. That's what the rule says. Okay. Okay. Anyhow, yeah, you all did quite well. Now let's take a look at this graph. And all these on the actual board. F of 3. How do you estimate f of 3? Well, if you're going to estimate it like on a test or something, you better show me how you're estimating. Okay, don't just write down a number. Show me. Okay, if this is 4 is here, so I say 2's here, 1's here, 3's here, so I say x equals 3. What would be about here? We go on the line x equals 3 until we hit the graph. Then we figure out what the y coordinate is. We draw the 2 lines, dotted lines, projection. Okay, and we get y equals, I think that's 8.4237. Or did I? So not less, did you? Okay. Somewhere around 8 or 9. Okay, if you estimated 8, fine. If you estimated 9, that's fine too. Okay. f of -1. Well, -1 would be about here. Your estimates are not going to be identical to mine because you're not going to draw the picture exactly the same as I did. Okay. And then really get -1 right. I think it should have been a little further over this way. But we labeled the line x equals -1. Items. Well, there's about y equals 5, so I think this is about, I would say 3.5. So if you estimate 3 or 4, that'd be a good one, right? And if you drew the graph a little differently, it's okay. Now f of 3 minus f of 2, well, actually I should write out my conclusions here. I haven't given myself enough room to do that. So I'm going to make it. I've already got these written down. I've written down the other four, so let's clear out this page. What I want to say here. Most of y'all are not close enough to see how to get all these decimal places in your estimate. So I'll just kind of round off to 8.4. Okay. And even with 0.4. Looks a little less than 9. Looks a little more than 8. Somewhere between 8 and 9, either. Again, with you. Okay. So again, since this point corresponds to x equals 3 and y equals 8.72, that's what our f of 3 is, okay? So f of -1 is approximately, what did I say, 3.5, right there it is in front of me. Okay. Okay, now we do f of 3 minus f of 2. Well, we don't yet know what f of 2 is, but of course, we can draw the x equals 2 line. It intersects the graph is up here. Okay. And we conclude that. Okay. So f of 3 minus f of 2 is approximately equal to 8.4 minus 11, which is negative 2.6. Fair enough? Okay. Solutions of f of x equals 4. We did it last time. You might not remember. Anyway, f of x equals 4 means y equals 4. So we sketch the line for y equals 4. The things are getting a little cluttered up there, so that's these points like so. We have a point here and a point here on the y equals 4 line. point is just a little bit to the right of x equals -1. It's kind of clumsy. Try to draw the projection line. But I'm used to being clumsy, so we'll do this. So this line is x equals -1. Let's just say over. Okay. Okay, so on this point, is approximately equal to, we're going to say 3.7. Okay, so I'll make a statement over here. Solutions of f of x equals 4. Well, say, well, y equals f of x in this graph. And I should have probably labeled the graph equals f of x. We sketch the line y equals 4. We locate the intersections with the curve that's here and here. And then I thought the word lines, but I didn't write it, did I? It's vertical lines. The intersection points. At your x coordinates. That's what I did. That's just words to describe it, to remind you. Okay, if you know this much about function notation, then you got a decent start. Okay. Then if you get into a pre-calculus class, it might not come back to you instantly, but it'll come back to you and you'll understand the idea. Okay. And you'll avoid making some common mistakes. That might be about all we need to really say about function notation. Okay. Now, there's another thing you really want to understand going into pre-calculus. They're many, we weren't able to go over all of them. And I'm leaving off a couple of things. Some pretty important aspects of algebra too. But had enough interruptions this semester that just can't get everything done. We'll touch on the last couple of things next week. Okay. But one big deal. I'm gonna write down a few equations. They're equations you can pretty much solve. Not gonna take time to actually solve them. 2x plus 5 equals 9. 4 times 3x minus 7 equals 12 times 5x plus 2. Okay, I think everybody can solve these equations. And of course, you're going to want to review for the exam because you're certainly going to see equations like this on the exam. What are you going to do with this one? That's one that always throws people. You got denominators, you multiply both sides by the common denominator. I'll probably go ahead and solve this just for review. So I'm going to go ahead and do this. Times 4 over x plus 3 equals x times 7 over x. Well, this is like x over 1. This is 4 over x. The x in the denominator divides the x in the numerator and leaves 4. X times 3 is 3x. X times 7 over x. X is divided by x leaves you 7. And now easy to solve. You get x. Okay. If you don't multiply by common denominators, good luck. Okay. You're not going to be able to solve that. Okay. No matter how hard I try to beat this into the heads of pre-calculus students, their heads are resistant to it. Never think of it. Okay. And if you tell them to do it, a lot of times they can do it, but a lot of times they can't. Okay. There's just something about that. It's just too weird in the brain. Okay. Well, no, it's a matter of practice and recognizing what you have. Now, the point here is that you have to recognize what kind of an equation you've got in order to solve. It's a linear equation. You got to multiply both sides by the common denominator. Plus 3x equals 7. Okay. Well, you go ahead and multiply by the common denominator, but what you're going to end up with is three x squared equals 7x. Okay. I multiply this by x, the x goes away, leave me 4. Multiply this by x, I'm going to get an x squared. Of course, multiply 7 by x, I get 7x. Okay. Anybody have any idea how to solve that equation? None of this stuff's going to work because you got an x squared and an x. So try as you might, you're either going to break the rules of algebra and screw it up, or is it you don't know enough rules of algebra to solve it. Okay. In most cases, now some of you maybe seen these before. Well, this equation could be written, subtract the 7x from both sides, it becomes 3x² minus 7x plus 4 equals 0. Okay. Now this equation now we're in the form a x² plus bx plus c equals 0. Okay. Solutions are, oh, we don't go on it. Okay. See what I mean in a minute. Solutions are x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Okay. Now, what's a in this expression? Can you show me with your fingers what's the value of a? A is the number in front of x squared, right? Can you find the number in front of x squared? Well, yeah, you can. It's 3. Okay. So it's that easy. You just, a stands for whatever's in front of x squared, and it goes here and here in the equation, right? But here. Okay. So tell me what you think b is. Yeah, it's negative 7. Okay. It's the number in front of x, always, if you're going to use this formula. Okay. And what do you think c is? 4. Okay. Well, okay. Now that you've identified a, b, and c, go ahead and replace, write out this expression, but replace b with the value of b, and a with the value of a, and c with the value of c. Okay, and as I said before, sign this, it's good to write a equals 3, b equals negative 7, c equals 4. Now, you really, in your notes, should have all this written out. Okay. At the very least, when you're doing this, you'd better have this to look at. Okay. Some of you, kind of copied it down from the board and didn't write this. It's okay because Open Math is going to tell you exactly the same thing. You're going to see plenty of examples. So it's not going to cripple you, but just in general, you want to get everything written out so you see exactly why you're doing what you're doing. Okay. And if you see it now, then it's going to be much easier when you see it in Open Math. But it's not hard. You're not going to have a lot of trouble. Okay. Now, we then get x. X is negative b. What's b? B is negative 7. So we write x as negative of negative 7. So we don't write 7. We write the negative of the negative because we really have to be careful about negative signs. It's real easy to make an error with the negatives. Now we got b squared under the square root sign, and b is negative 7. And incidentally, some people want to write negative 7x for b, and that's not right because b is the number in front of x. B doesn't include x, right? And I see that in pre-calculus classes. If you put an x in there where it doesn't belong, then you're going to get some besides numbers. This is just going to give you a number. Okay, well, then we have minus 4 times a, which is 3, times c, which is 4. I think everybody's got that. And then we've got 2 times a, 2a, that's 3. Okay. Now we've got to keep our wits about us and simplify this. First of all, the negative of negative 7 is plus 7. And this should be negative 7 squared. See how I left off the symbol there, right? But I know that has to be squared, so when I get down here, did see the square, I caught it. When you're first doing it, just be more careful than I just was, okay? But you're gonna square this -7, that's gonna give you 49. And then 4 times 3 times 4, 4 times 3 is 12, times 4 is 48. Well, that's over 6. So what we then have is 7 plus or minus the square root of 1, 6. And the square root of 1 is 1. So it's 7 plus or minus 1 over 6. Now I haven't left myself quite enough room, but I wanted to make sure about this. Okay? Everybody understand? You just got to be careful. Get the numbers in there, do the arithmetic. Watch out for negative signs. Okay, now what is 7 plus or minus 1 over 6? Well, that means either 7 plus 1 over 6 or 7 minus 1 over 6. Okay? It's two solutions. Now, just to give you the idea why you get two solutions, it's like this curve. We get two solutions. Okay? There's a number in the middle, which in this case would be 7 over 6. And then it's plus or minus 1 over 6. Okay? This would be like if this is, I don't want to keep the numbers. And I don't want to say that much. I do want to say that much, but the judgment tells me I should. Okay. Whole point is, you take the number in the middle here. You get that number plus some number that gives you this one, and that number minus the square root, which gives you this one. So it's like you got the middle plus the square root, the middle minus the square root. If you understand that, it's good, but you don't have to understand it. Okay. Now I'm going to do a little work here. So I'm going to this equation, rearrange to this equation. And you should be able to do that rearrangement. But at this point, it's not a big deal, as long as you know, at least with linear equations, to multiply by the common denominator. That's how it came about. We multiply by the common denominator, this equation, and we get this equation. We subtract 7x from both sides and get this equation. Okay. Now again, where we are, you know how to solve linear equations, unless I got a denominator. And then hopefully you know to multiply by the denominator. An equation that looks a whole lot like this one, but with an x on that 3 ends up giving you the quadratic equation. Quadratic equation is an equation of this form. Some multiple of x squared plus a multiple of x plus a number equals 0. Has to be in that form. If it's in that form, then you got a formula for your solution. Okay. In pre-calculus, hopefully you'll see where that formula comes from. But I'm not going to touch it here. Okay, so I say 7 plus or minus 1 over 6 equals what? Seven plus 1 over 6. Seven minus 1 over 6. Okay. And that equals six over six, which we can reduce to 4/3. How about this? If we were to graph this function, it would have a parabolic graph. Out here at x equals 4/3, it also, at x equals 1, the value of this expression is 0. So the solution to this equation gives you 2 points on the x-axis. Okay? Then you know that this solution is parabolic. So now there's a lot more. Then you study this kind of stuff in pre-calculus. But right now, since we've just dealt with function notation and graphs, in the concept of graphs, again, it's a little extra bit. I'm not going to test you over it, but if you set that function equal to 0 and use a quadratic formula, you know where it hits the x-axis, and you know it has the shape of a parabola. And then there's other information that you can get, like if x equals 0, we know that this is equal to 4, so then we know that the line y equals 4 is here. Start getting a lot of information about graphs. You do a lot of that sort of stuff in pre-calculus. So, and this isn't just applicable to graphs. There's a lot more I could say, but not going to get into it because we want to just get the mechanics done right now. It'd be nice if we get a little more than that done, but let's be realistic. Okay. So I'll cut through it. Okay. Try x squared plus 5x plus 6 equals 0. Three x squared minus 3x minus 18 equals 0. And x squared plus 2x plus 5 equals 0. Give you a few minutes to work on those, and I'll just come around and see how you're doing. Okay, everybody is doing real well with this. Sometimes a little error that you want to get your tasks now so you don't get hung up on it when you do them for homework. So let's do x squared plus 5x plus 6 equals 0. And as I've recommended to several people, make sure you've got the quadratic formula. Form the function has to be in. If you don't have equal 0, this isn't going to work. Okay. And then the formula itself, so you can look at it. Okay. So we're going to say, okay, A equals what? Well, we just talked about it a little bit, but you just got x squared. You don't have anything in front of x squared. Well, 1x squared means the same thing as x squared, right? So if you just got x squared, it could be 1x squared, and that tells you that A equals 1. And I said before, I think, well, how many x squareds have you got there? You got 1. How many x squareds have you got here? You got 3, right? Okay, so A equals 1, B equals 5, C equals 6. So x equals 5 minus the square root of 5 squared. No negative involved here. Now, there's no negative in front of b squared. Now, if b happens to be negative, there is a negative on b, but you put parentheses around it, squared. Okay, so you got 5 squared, then it's minus 4 times a, which is 1, times c, which is 6. All that divided by 2 times 1. Five squared is 25. 4 times 1 is 4, and then times 6 is 24. So we get that. And that's negative 5 plus or minus the square root of 1 over 2. It's negative 5 plus or minus 1 over 2, because the square root of 1 is 1. Negative 4 over 2. That'd be negative 5 plus 1. And negative 5 minus 1 is negative 6 over 2. Equals negative 2 or negative 3. That makes sense? So you just got to be careful, get the bookkeeping right with a little practice, you won't have any trouble. Okay, and then we've got our 3x squared minus 3x minus 18 equals 0. Incidentally, you might notice you factor 3 out of this. 3 is a common factor. And you can reduce the numbers a little bit, because you divide both sides by 3, you don't change the solutions. Okay, so you could do that. And it's one of the things sometimes you want to look for, but I'm not going to stress it right now. I'm going to use a quadratic formula. Say, okay, A is 3, B is negative 3, C is 18. Let's deal with a slightly bigger number. So we have negative B, which is negative of negative 3. Negative B is negative 3. That's going to be square root of square of negative 3. Make sure we put parentheses around negative 3, so we square the negative sign as well. Otherwise, you might end up with a negative sign on this thing. That's not going to happen with square. Okay. And then it's minus 4 times 3 times 18. Times 3. That gives you 3. This 18 is negative. C is negative 18. Don't make that mistake. I pretended to make it just so you'd see that it throws things off. Okay. Well, I really made a joke. Anyhow, 4 times 3 is 12. 12 times 18 is 216. And a minus gives us plus. So 9 and 216 is 225. Is 3 plus or minus 15 over 6. The square root of 225 is 15. That's going to give me 18/6, or 12/6, negative 12/6, which equals 3 or -2. Make sense? Something's wrong with that. Because if I factor that, find that the solution is -3 and 2. And never mind. Those are the solution. Pretend I never said that. Okay, so let's just take this one and solve it here. We got well, I don't have to write it again, do I? It's going to be 1, B is going to be 2, C is going to be 5. So the X is -2 or minus the square root of 2 squared minus 4 times 1 times 5, all divided by 2 times 1. Well, that's -2 plus or minus the square root of. We're not going to do the intermediate step. 4 times 1 times 5 is 20, but it's negative. So 2 squared is 4. We're going to have 4 minus 20. And if you just do it, you're going to get -16. And a lot of you did. So, okay. Now the question is, what are we going to do with the square root of -16? You might want to say the square of 16 is 4. And 4 squared is 16. It's not -16. Or you could say, well, let's try -4. Well, -4 times -4 is +16. Well, you can multiply two negatives whenever you square a number. You can't get a negative sign when you square a real number. So what we do, -16 is 16 times -1. So we can write the square root of -16 as the square root of 16 times the square root of -1. Now we don't know what the square root of -1 is. It's not a real number though, because you can't get a negative by squaring a real number. Anyhow, that's over 2. Well, we say that's -2 plus or minus. There's a square root of 16 is 4. And we're going to say the square root of -1 is I. Now, why do we call it I? Well, I say that no real number can have a negative square. So if the square is negative, that number's got to be imaginary. It's not real, it's imaginary. So I stands for imaginary number. And then we can here divide 2 into both of these. We get -1 plus or minus 2i. I is not something you can graph on a set of xy coordinate axes. It's an imaginary number. Okay. And it has all kinds of implications. I spent 2 years of graduate school intensively studying. Okay. It's a huge area of mathematics based on this, on the calculus you get when you assume the function of a complex variable has derivatives that make sense and go down a rabbit hole from there. Okay. So it's a big deal. But if you're not going to be a physicist or an engineer, philosophically, it's a big deal because it turns out that these things have to be in some sense real because some things in quantum mechanics require that they have actual physical presence. Okay. And I can't explain the reasons for that to you. I don't know. I'm not even sure that's a solid conclusion, but I kind of think it is. Okay. There's evidence that these imaginary numbers that were created close to 200 years ago, around 200 years ago. I don't remember exactly when. I was very young at the time. But interesting how they turned into a big deal. But that's one thing you probably want to see. So you are, because you are going to see it in any course more advanced than this. Okay, good. Y'all did real well. Get the homework done. I don't think it'll give you much trouble.